All right, guys, Mr. Antonucci here, and in this video, I want to show you how to solve for the unknown integral when you're using integration by parts. Sometimes when you have a problem that you're asked to anti-differentiate and you have to use integration by parts, you end up starting to go in circles once you do the integration by parts a couple times. So I'm going to go through an example with you of what to do when that happens. So here we're asked to find the antiderivative of e to the 2x times sine x. If we go through the strategy that I taught you, LIPE it, to identify what we're going to use for the u. So logs, none. Inverse trig, none. Polynomial, none. Exponential, that's what e to the 2x is. So u is e to the 2x, and then our dv, is going to be sine x dx. I really like this example because it incorporates a lot of the things that sometimes trouble students, including repeated use of integration by parts, solving for the unknown integral, negatives and distributing, all kinds of good stuff in this one. Okay, so u is e to the 2x, so du is 2e to the 2x, and v is going to be the antiderivative of sine, which is negative cosine x. So our integral, I'm just going to rewrite it right here, is e to the 2x sine x dx equals uv, so negative e to the 2x cosine x minus the integral of v du. The negative is going to factor out and multiply this negative, make it positive, and I'm going to factor out this 2. So it's e to the 2x cosine x dx. Okay. Now, again, we still have e to the 2x and a cosine. So in this case, if I follow my LIPE rule, again, the u is going to be e to the 2x, and my dv is going to be cosine x. Okay. Now, du is going to be 2e to the 2x, and v is the antiderivative of cosine, which is sine x. Now, at this step, I have negative e to the 2x cosine x plus 2 times the integral of e to the 2x cosine x. Which by integration by parts is uv, so e to the 2x sine x minus the integral of v du. I'm going to factor this 2 out and get e to the 2x sine x dx. And you'll notice that this integral right here is the original integral that I started with. And so we would have to do integration by parts again, theoretically, which would then just lead us into a big circle of doing this again and again and again. It would never end. But since this is equal to the original integrand, I can actually solve for the original integrand by collecting like terms, just like you did way back in algebra. So let me simplify this out and I'll show you what I'm talking about. So you have negative e to the 2x cosine x, and then this 2 is going to distribute, and you get 2e to the 2x sine x, and then minus 4 times the integral e to the 2x sine x dx. All right, now that whole expression is equal to the original integral, which is e to the 2x sine x. So what we could do is take this and add it, plus 4 that integral, to the other side, because they're like terms, which would give you 5 times the integral e to the 2x sine x equals negative e to the 2x cosine x plus 2 e to the 2x sine x. Now, you just divide the 5 off, and you have the original integral solved for. So if we divide everything by 5, divide this whole side by 5, you would have the integral of e to the 2x sine x equals negative 1/5 e to the 2x cosine x plus 2/5 e to the 2x sine x plus c. Boom, you're done. All right, so I hope that was helpful to you in solving for the unknown integral using integration by parts. If so, give me a like on this video. Make sure you subscribe to the channel and hit the bell for notifications when new videos are uploaded. And if you have a video that you'd like me to make, or if you have a problem that you'd like me to make a video of, put it in the comments below and maybe I'll make a video about it. All right, guys, take care.